What's up, calculus students? Let's do the homework 3, where we learn about the curvature of a function. And we learned that if f prime is increasing, the only way for f prime to be increasing is if your function is curving up. And if f prime is decreasing, your function must be curving downward. Now you got two ways. You got like curving downward and going up, curving downward, going down, but it's all about curvature and f primes increasing or decreasing. What we did last class was we examined the sign of f prime. And just as an example, if f prime changes from positive to negative, you know f is going up or going down. Well, now to figure out if f prime is going up or going down, we need to analyze the signs of our second derivative. And if our second derivative is positive, f prime is increasing. If our second derivative is negative, f prime is decreasing. But what we're going to do is say, like, okay, f double prime positive, f prime increasing, f is curving upward or is concave up. If f double prime is negative, f prime is decreasing, f is concave down. So, like, signs of derivatives tell us if something's increasing or decreasing. Okay, to find out if f prime is increasing or decreasing, we need to look at f double prime. And then when f prime is increasing, we know we are concave up for f. Here we know we're concave down for f. All right, so we need to figure out if f prime is increasing or decreasing. We need to go to the second derivative and do a sign analysis. If your concavity changes at a point, wherever this point is, this would be considered a point of inflection. So I blow past the first derivative and go to my second derivative. Set this equal to 0, or see when this is undefined. For this situation, I get 0. Again, f double prime signs, they're going to be negative, then positive. There's 0 at 0. Plug in something like 1, plug in something like negative 1. That's telling me f prime goes up, goes down, which tells me f is concave up, concave down. Okay, you could skip this middle line and go straight here, but I like to have all three down just for now, just so we're comfortable with, like, a sign of a derivative tells us if the step above it is increasing or decreasing. The sign of f double prime tells us if f prime is increasing or decreasing. The sign of f prime will tell us if f is increasing or decreasing. Let's see this one. 4x cubed minus 3. Blow past that. Becomes very similar. 12x squared. Set that equal to 0, or see when it's undefined. I don't have to worry about the undefined. There's no denominator. I just get x equals 0. Signs don't change, though, because, like, if I plug in a positive squared, it's positive. Plug in a negative squared, that's positive. So that means f prime is increasing, flattening out increasing, which means f is concave up. No concavity, concave up. Here I say x equals 0 is a point of inflection. X equals 0 is not a point of inflection. X equals 0 is a point of no concavity, but we are not changing our concavity, so we don't have a point of inflection. And I'm going to write that down. X equals 0. Not a point of inflection, but is a point with no concavity. And no concavity means no curvature. Like this here, f prime would be constant. F, no concavity. Here, f double prime, positive. Here, f double prime, negative. Here, f double prime, 0. Next one. Sign of my second derivative. Come in. Plug in something like 4, positive. Plug in something like 0, negative. I'm plugging into this. Yeah, just put it on 40. All right. It's telling me f prime is decreasing, then increasing. It's telling me f is concave down, then concave up. X equals 3 would be a point of inflection. Curving downward, curving upward. That's all we know. We're not even going to try to sketch. Like, the best way to sketch is to have your analysis of f prime to figure out if you're going up or down, and then to combine that with f double prime to figure out like how you're curving as you're going up. If you're curving downward while going up or curving upward while going up. So I'm not going to sketch anything. You can't really sketch based on curvature. This is just good to know the curvature. If we combine it with last class, which we will next class, combine the two things. That'll be easier. All right. Negative 4, 6, which is negative 2/3 x cubed plus 3x squared. Negative 2x squared plus 6x. Factor out a negative 2x, x minus 3. You don't have to factor out the negative if you don't want to. Hey, let's do it during class today, because I'm going to see you seventh period.
Okay.
So
Okay,
let's
sounds
fix
good.
it then. Okay. So I get x equals 0 and 3. Zero, 3. Checking signs, paying attention to this negative 2. If I plugged in something like 5, it'd be negative 2 times 5, which is a negative. 5 minus 3 is a positive. If you need to do it over here, f double prime at 5, negative 2 times 5 times 5 minus 3. Do it. Do it. Negative times positive, negative. If you use multiplicities, like the multiplicity of like our roots are both 1. There's only like a power of 1 over the x and the x minus 3, which means we will change signs. If you're not comfortable using multiplicities, like here, this multiplicity was 2, which is why I don't change signs. You can use multiplicities. If you're not comfortable, don't use it. Just check on all your intervals. It's always safe. Okay, so f double prime is negative, positive, negative, which means f prime is decreasing, increasing, decreasing, which means f is concave down, concave up, concave down. All right, so x equals 0 and 3 are both points of inflection, and this is the curvature. Curving upward, curving downward, curving upward, curving downward. $72x. Oh, that'll be fun. 12x squared minus 12x minus 72. I'm going to factor out a 12. X squared minus x minus, what's 72? 6? Yeah, 6. I'm going to factor this. X minus 3, x plus 2. Don't have to worry about the undefined part. I get 3 and negative 2. Throw those down. Here's f double prime. I'll do a sign analysis. Mm-hmm. Zero's here, so points of no concavity. I'm making a video. You're good. Plug in something like 4 or 5 positives. Multiplicities are 1, so the signs are going to be changing. Tells me about f prime going up or going down. F prime going up or going down tells me about the curvature, the concavity or the curvature of f. F is concave up, then concave down, then concave up. So these are both points of inflection, and here's the curvature: curving upwards, curving downwards, curving upwards. So just drop it there. You're good. A lot of freshmen this year. Good to see. All right. This will turn into negative 1/4 x to the fourth minus 1/2 x squared. Second derivative will turn into negative x cubed minus x. Cool. Set that equal to 0 or undefined. Pull out a negative x. I do this so I get positive x squared plus 1. I wonder if I wanted one of these to be positive, but it's not. Uh, a lot of people think that x squared plus 1 can be factored, but it can't. Like, try to set x squared plus 1 equal to 0, and you get x squared equals negative 1, which means x equals the square root of negative 1, which is an imaginary number. It's I. We don't have to worry about i's, so we're just going to disregard this. There's no real solutions that come from this. The only real solution for this is 0. So let's look at what happens at 0. X squared plus 1 is always positive. No matter what I plug in for x, I square it, it'll be positive. Add 1 to it, it'll be positive. So if I plug in something like positive 1, it'd be negative 1 times positive 2. That's a negative. If I plug in something like negative 1, it'd be the opposite of negative 1, which is a positive, times positive 2. So that would also be a negative. So f double prime is negative than negative, which means f prime is going down, going down. When f prime is going down, f must be concave down. So x equals 0 is not a point of inflection. Do you have a first period? Do you have a first period? You do? Okay. Well, then why don't we work on this during your class period when you have more time? Because you only have 20 minutes to start. I mean, you could do it for 20 minutes and then come back during the class period and finish it. You see every class period today. You go 1/4, 2 5th, 1/5, 2 6, 3 7. Okay. So not a point of inflection, but it is a point of no concavity. Most of these problems people have no problem with. It's like the same thing that we've been doing, just with a second derivative instead of a first. When we get to the graphs is when people really struggle. So we'll make sure we pay attention and we focus when we're doing the graphs. I'm going to pull out 20x squared here, giving me 3 minus x. 0 and 3. F double prime signs. If I plug in something like 4, positive, negative. Multiplicities are 1 and 2. So we'll change sign at 3. Will not change sign at at 0. Let's double check that. Let's plug in negative 1. Negative 1 squared. Yeah, just drop it off with that pile. Negative 1 squared positive times 20 positive. 3 minus negative 1 positive. So that checks out. That's positive. If I plug in 1, 20 times 1 squared, boom, positive. 3 minus 1, boom, positive. So that means f prime is increasing, increasing, decreasing, but that means f is concave up, concave up, concave down. We do have a point of no concavity. This is not a point of inflection. X equals 3 is the only point of inflection where our curvature changes, curving downward to upward. or in this case, curving upward to downward. This will be fun. 6. So it's very important. And a lot of people forget, like x to the 6 over 30th. Everybody's like, oh, what do I do here? Do I have to use the quotient rule? No, rewrite it as 1/30th times x to the 6th. Just making sure we understand, like, don't let this fraction freak you out. With constants, you can rewrite. So I can rewrite it like this. So if I'm taking the derivative of 1/30th x to the 6th, it's the same as x to the 6 over 30, which will be 6 times 1/30th, which is 1/5 x to the 5th. It's the same thing with this. This is 1/20th x to the 5th, which will turn into 1/4 x to the 4th. This will be minus 4x cubed. This was plus 3. Let's go again. I get x to the 4th minus x cubed minus 12x squared. Set this equal to 0 undefined. I'm going to factor out an x squared. No denominator, don't have to worry about that. I will factor this to be x minus 4x plus 3. I get -3, 0, and 4. Throw those down. F double prime signs. This is where multiplicities help us. Multiplicity is 1, multiplicity is 1, multiplicity of 0 is 2. So let's just check at 5. Positive, positive, positive. At x equals 4, the x minus 4 has a multiplicity of 1, so I will change signs at x equals 4. At 0, I will not change signs because the multiplicity of the x squared is 2. Will not change signs. At -3, I will change signs. The multiplicity is 1. Maybe you remember that. If not, you could always check. Let's plug in something like -1. Positive, negative, positive, positive, negative, positive is negative. Okay, that's a good one to check. -4, positive, negative, negative, positive. Good. All right, so f prime going up, going down, going down, going up. F concave up, concave down, concave down, concave up. X equals 0 is not a point of inflection, but -3 and 4 are points of inflection. X equals 0 would be a point of no concavity, but not a place where our curvature changes. Got a trig function here. Derivative of sine is cosine. 1/4 x squared would be 1/2 x. Second derivative. Set that equal to 0, see when it's undefined. No denominator there. Add 1/2, divide by -1. Sine x equals -1/2. I'm only looking at between 0 and 2 pi. So if I'm throwing down a number line, I have a starting point and an ending point. Sine's a half at the pi over 6's, the 30 degrees, where the opposite is 1/2. Sine is negative in the third and the fourth quadrants. So I need this pi over 6 and that pi over 6. That's going to be 7 pi over 6, which is 1 pi over 6 more than 6 pi over 6. And this is 1 pi over 6 less than 12 pi over 6, or 11 pi over 6. I'm going to go back to this f double prime to check my signs. I'm going to plug in values that are easy to plug in to sine, like pi, like 3 pi over 2, and 2 pi. 2 pi is a good one to check because the next 0 is going to be all the way around the circle again, back to here, which will be 19 pi over 6. So 2 pi is a good one to check. So if I plug in pi, the sine of pi is 0. So 0 minus half, negative. And again, I'm checking f double prime signs. 3 pi over 2. The sine of 3 pi over 2 is negative 1. So I have the opposite of negative 1, which is positive 1 minus a half. That's a positive. And let's just make sure we know how to do that. Negative sine 3 pi over 2 minus a half. Sine of 3 pi over 2 is negative 1. So it's negative 1 minus a half. So that's positive 1 minus a half. That's why I say that's positive. 2 pi, the sine of 2 pi is 0 minus a half. That's negative. All right, so f prime is going down, going up, going down because the sine of its derivative is negative and positive. It's f prime, which means f is concave down, no concavity, concave up, curving up, no concavity, concave down. So both 7 pi over 6 and 11 pi over 6 are points of inflection. Okay, we see this one a lot. First derivative. Derivative of negative cosine is positive sine. Second derivative. Derivative of cosine is negative sine. And we set this equal to 0. Again, we could turn this into a tangent by subtracting cosine and dividing by cosine. Or you can add the sine and then divide by cosine. You end up with tangent equals positive 1, like the negatives cancel, or if you add the sine, it's cosine x equals sine x, divide by cosine 1 equals tan x. Tan is equal to 1 at the pi over 4s when tangent is positive, which is pi over 4 and then 5 pi over 4. Good test points would be at like pi over 2 or pi, 3 pi over 2 or 2 pi. 0 is a good test point. The next 0 is at the coterminal angles to pi over 4 and 5 pi over 4. So like even though it's an endpoint, 0 and 2 pi, they are good test points to use because it's not going to be a 0. You're not going to change signs. The next time you change to a 0 would be at negative 3 pi over 4. Go back to f double prime. Let's plug in 3 pi over 2 or 2 pi. It doesn't matter. Sine of 3 pi over 2 is negative 1. Again, I'm taking the opposite of negative 1. That's positive 1. Cosine of 3 pi over 2 is 0. So that's a positive. Let's check if I did 2 pi. Sine of 2 pi is 0. Cosine of 2 pi is positive 1. So that's also positive. So that checks out. Pi over 2, the sine of pi over 2 is 1, but I'm making it negative. So negative 1 plus the cosine of pi over 2 is 0. So that's negative 1. 0. Sine of 0 is 0. Cosine of 0 is 1. So these are my signs of my second derivative, which is telling me f prime is going up, going down, going up. It's telling me f is concave up, concave down, concave up. Points of inflection, both pi over 4 and 5 pi over 4. Okay, seems like it's the same question as we've been doing, but pay attention to what we have. I'm given f prime. Questions asked about f, not about f prime's concavity. It's like f's concavity, f's curvature. So since this is f prime, all I need to do is take the derivative one more time to get the second derivative. Analyze the signs of my second derivative. Don't love this one, but it's fine. Because I factor out a 3 and I get x squared minus 3. Now, there are solutions to x squared minus 3 equals 0. It's a good one to do, though, because not always will we get whole numbers. X equals plus or minus root 3. You could factor this to be x plus root 3 times x minus root 3. If you wanted to, I actually think it's probably easier to not have it like that and just to use this as my simplified f double prime, zero is not a solution. It's like just because I have this 3 factored out doesn't mean zero is a solution. But I do have this plus or minus root 3. Now, watch, like root 3, what is it? I don't know, somewhere between 1 and 2. I could plug in 2, I could plug in 3, I could plug in 4. Let's plug in 4. 3 times 4 squared minus 3. 4 squared minus 3 is positive, times 3 is positive. Plug in 0, that's a good one. 3 times 0 squared minus 3, that's 3 times negative 3, that's a negative. Plug in negative 4. Negative 4 squared, positive, minus 3 stays positive, times 3 stays positive. Okay? So f prime increases, decreases, increases, which means f concave up, concave down, concave up. So both of these are points of inflection. When does f have points of inflection? Well, look at that. I'm given f double prime already. I've given you everything you need. F double prime already factored. All you need to do is look at the zeros, which are 0, 3, and 4. Do a sign analysis. Great to use multiplicities here. Sweet. Multiplicities. The 0's multiplicity is 2. The 4's multiplicity is 4. Those are both even, which means we're not going to change sign at 0 and at 4. Multiplicity at 3 is 1, so I will change sign. If you're not comfortable using multiplicities, just test your intervals one at a time. Plug in like 3.5. Plug in like 5. I'll start with this interval, and I'm going to use multiplicities just because it's quicker. Plugging in 5, positive, 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 positive. Don't change sign at 4. Change sign at 3 because the multiplicity is 1. Don't change sign at 0 because the multiplicity is 2. Even multiplicities bounce. Don't change signs. Odd multiplicities pass through or bend through. Change sign. Don't change sign. Okay. So this is telling me f prime is decreasing, then decreasing, then increasing, then increasing, which is telling me f is concave down, concave down, concave up, concave up. We only have one point of inflection, just at 3. 0 and 4 are points of no concavity. If I ask you when is f concave down, f is concave down on these intervals. When x is less than 0 and from 0 to 3, that's when f double prime is negative or when f prime is decreasing. Okay, now let's do the tough ones, the graphs. This page, I'm giving you f prime. This page, I'm giving you f double prime. Or I'm giving you f. You got to understand what you have, what you need. What's good to remember is the following for all of these graph problems. This relationship. A sine of f double prime, which maybe changes, whatever. I'm just giving you this as an example, means f prime is increasing or decreasing, which means f is concave up then concave down. Okay? All right. If I'm given f prime, there are two things that I could get. I could either look at f double prime sines. F double prime sines can be gotten by looking at the slopes of f prime, right? The derivatives of f prime are f double prime. I could look at that. I could look at when f prime is increasing or decreasing? I could look at that. And either of these will then tell me what f is doing. Concave up, concave down, curving up, curving down. Okay? I'm going to do the easiest way, which is I think is just looking at when f prime is going up. Then when f prime is going down. F prime is going up until 0. Then it's going down. That means f prime is increasing, then decreasing. That means f is concave up, then concave down. Okay? That's one way you could do it. The other way to do it is to look at the slopes of f prime and to find the signs of f double prime. It's just like when we sketched graphs of derivatives. We'd say that slope is positive. That slope is positive. That slope is positive. Less positive, but still positive. That slope is 0. F double prime is positive until 0 when it's 0. And then this slope is negative. This slope is negative. These slopes are negative. So I can either look at the slopes of f prime to do this top row and then confirm, okay, yeah, f prime is increasing and decreasing. And then boom, got concavity. You're going to first period first, Miller.
Okay, I didn't come because I thought it was class. I just a few questions. So like my first period teacher was absent, so I just told me to. So it doesn't matter actually. But I just came to ask like what we're doing today because we have.
We're working on the homework.
Okay.
That's due next class.
Missing homework.
Just turn it in during class.
Okay. All right.
Okay. Yeah. So when does f have points of inflection? At x equals 0. When is f concave up? When x's are less than 0. You could also say from negative infinity to 0. These are the same answers. Okay, and I could have given you the interval notation, negative infinity to 0 and 0 to 3 here. Okay, here's another one. Okay, for concavity, I can look at the signs of f double prime, if f prime is increasing or decreasing, and that's going to tell me about f and its concavity, its curvature. I'm going to do the slopes. F double prime can be looked at if you look at the slopes of f prime. Okay, so I'm going to do this first, and then I'm going to confirm by looking at f prime going up and going down and stuff like that. So these slopes are positive. These are positive, positive, less positive. This is 0 slope, negative slope, negative slope. That's another 0 slope, positive slope, positive slope. So I have positive f double prime signs because the slopes of f prime are positive until negative 1, where I have a 0. Negatives until 1, and then positives after that. That would be one way to look at it. The other way to look at it is to say, oh, here's when f prime is going up, increasing. Here's when f prime is going up. So f prime is going up here and going up there. F prime is going down here. F prime going down. Either way, you do it. This way or this way. Slopes or going up, going down of f prime. You know f is concave up, then concave down, then concave up. Points of inflection, when concavity changes, curvature changes. Both of those are points of inflection. Concave down, when f double prime is negative, when f prime is decreasing, that's when f is concave down. You can either write it like that or like this. Okay? I'm going to go straight to f prime increasing or decreasing. I will confirm with the signs of the slopes. Boom, concavity. Here's f prime going up. Here is f prime going down, where I've shaded in yellow, slopes are positive. Slopes are positive. When I've shaded in green, slopes are negative. Here, zero slope, here, zero slope, here, zero slope. That's when f prime is constant. So, negatives until -2, f prime is decreasing until -2. Whoops. Positives until 0, f prime is increasing. Negative slopes, sorry, that's f double prime. It's the slopes of f prime. Negative slopes of f prime until 2, f prime decreasing. F prime finishes off by increasing. We can confirm the slopes are positive. F is going to be concave down, no concavity, concave up. So that's a point of inflection. No concavity, concave down, no concavity, concave up. So -2, 0, and 2, points of inflection, concave up, -2 to 0, and 2 to infinity. Which you can also write as -2 to 0 and bigger than 2. Okay, what's going on here? Let's look. Don't focus on this point. Just let's not focus on it. Let's just do what we've just been doing. F prime going down, going down, going up. Don't like that? Slopes. Negative slopes, negative slopes, negative slopes, negative slopes, negative slopes, negative slopes, positive slopes, positive slopes. Okay? So, f double prime, slopes of f prime, are negative until this point where there is no slope. It is this open circle. It's a jump. There is not a tangent slope at the location of a jump. So the slope of f double prime, that's undefined. But from this point at 1 to this point at 2, we can see the slopes are negative, and then the slopes change to be positive. Or you could say f prime is going down. It's not doing anything. Then it's going down. Then it's going up. F, therefore, whatever it looks like, don't worry about what it looks like. Just this is your analysis. F is concave down. Maybe it's a vertical tangent. Maybe it's something else weird, whatever. Just do the analysis, then answer the questions. Where do we change concavity? Just at 2, where I go from concave down to concave up, curving downward to curving upward. So, boom, that's my answer to that question. When are we concave up? When f double prime is positive, when f prime is increasing. Here, this interval, x is bigger than 2, or you could say 2 to infinity. That's it. Don't let this freak you out, okay? Now, next class, when we combine what we did this last class with this class, then we'll have to worry about what it might look like. And you'll see it's no big deal. What happens at 1 is we end up having a sharp point where we go from decreasing concave down to increasing concave down. The only way you can go decreasing concave down to increasing concave down is at a sharp point. Now, this is where people get really tripped up because you got this. It's like, I got this. I understand what I'm doing. I'm just going to do this every single time. But it's not going to be the case now because I might give you something else. Here, This is no longer the graph of f double prime. If you do what we just did, you are not going to be doing it right. If you say, oh, this is when we are going up, this is where we're going down, and this is what I'm supposed to do when I'm given a graph, is do what we just did, you're wrong. This is going to be wrong. If you're like, oh, positive, then negative, f prime is going up, then going down. No, 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 no. You have f double prime going up, then going down. This is not it. This won't be it. It's not right. In this situation, understanding this is what we're looking for. Either f double prime signs or f prime going up, going down. This is what you have to use. Since you are given f double prime, the easiest thing to do is to look at this, the signs of f double prime. It's like what we did in last class when I gave you f prime and I said, look at the signs of f prime. And when I gave you f prime, you said, oh, it's positive, 0, negative, 0, positive. That's what you're going to be doing here because I want to figure out the signs of f double prime. Well, f double prime is 0 when it hits the x-axis, if this is the graph of f prime, f double prime. When its y coordinates are 0. When its y coordinates are positive, f double prime is positive. When its y coordinates are negative, f double prime is negative. So actually, f double prime has negative values until negative 3, positive values until 2, and then negative values after 2. It has a 0 at negative 3 and a 0 at 2. I don't see f prime, so I can't tell when f prime is increasing or decreasing. But now I do know, based on the signs of f double prime, that f prime must be decreasing, increasing, decreasing. That means f must be concave down, concave up, concave down. Where do we have points of inflection? Negative 3 and 2. Where is f concave up? Between negative 3 and 2. Where f double prime is positive, it's where f prime is increasing. Okay? Tricky. You're given f double prime. The only way to figure out concavity of f is to look at the signs of f double prime. Negative values of f double prime until negative 2, where I have a 0. Positive values until 0. Negative values until 2. Positive values after that. F prime, therefore, must be decreasing, increasing, decreasing, increasing. We honestly can skip this whole f prime analysis because f double prime signs tell me f's concavity. Sorry, these are zeros. That's a 0. This is a 0 at 0. So f is concave down, then concave up, then concave down, then concave up. Where does f have a point of inflection? Where does its curvature change, its concavity change at negative 2, 0, and 2? When is f concave down? Here and here when the second derivative is negative. So you could say negative infinity to negative 2. You could say 0 to 2. You could have also said x's are less than negative 2 and between 0 and 2. That's one way. The other way, those are both of the ways, and that's when f double prime is negative. Do you want to check in with your first period teacher? Do you want to check in with your first period teacher? First period, then fifth period, then second period, then sixth period.
Second, first, fifth, second.
Yeah.
Alright.
Just tell him to email me so you don't get Mark tardy if he has any questions about where you were or her. All right, finally, I'm giving you a question and I'm giving you the graph of f. Thanks. Where does f have points of inflection? Well, like, I mean, I guess for points of inflection, I could look at second derivative signs. I can look at first derivative increasing, decreasing. Or I guess I could just look at the concavity of f. We are now looking at this line because I'm given f. I'm asked about concavity. Well, I just have to look at the concavity. F is opening upward until it looks like, and you'd be told where this point is on a quiz or something. We are concave up when we're opening upward. We are concave down when we are opening downward. Okay, so where does f have points of inflection? It looks like x equals 1. You'll be told what that is. But this is the question that you would most likely see. When is f double prime positive? F double prime positive, how do I do that? Well, like, if f is concave up, f double prime is positive. Like, these are all in a row. So if f is concave up, this must be the region when f double prime is positive. So it's like second derivative is positive, means the first function must be concave up. F is concave up here when x's are less than 1 or from negative infinity to 1. Three different graphs, three different situations. Don't memorize what to do when you see. What you're gonna have an understanding of is this table that you create. And this table leads you to knowing, okay, based on what I have, what can I do? Okay, let's look at this. And I'm gonna go straight to this one. When is f double prime negative? Well, when f double prime is negative, f prime is decreasing, f is concave down. Now you will be told this, but you can see here's f. The question really is, when is f concave down? Well, you'll be told that there's going to be a point of inflection here, and it looks like there's a point of inflection here. You can see this is when our graph is opening downward. Our curvature is downward. I don't care that it's going up and then down, it's just curving downward. That between -2 and 0 is when I'm curving downward. Okay? Where does f have points of inflection? It looks like at -2, we're shifting from curving upward, concave up, to concave down, to concave up. So I would say -2 and 0. You would be told that specifically. You're just kind of guessing here. It's the graphs that people have the most problems with. It's understanding what you're given, how you can fill out this table to then analyze curvature. If you're given f prime, look at when it's going up or going down. That's easy. Or look at the slopes of f prime. You can find that too. If you're given f double prime, you can't figure out when f prime is going up or going down. But what you can figure out easily is when f double prime is positive or negative. Here's f double prime. When does it have positive values? When does it have negative values? If you're given f, look at the concavity of f, and you'll be able to answer questions about when f prime is increasing, decreasing, or when f double prime is positive or negative. Okay? So redo the graph questions if I have any advice to you, because most people have no problems with sign analysis of just a second derivative. It's just the same thing, just taking the derivative twice instead of once. It's the graphs. Don't memorize what to do. Understand the table that can be created that can help you lead you in the right direction. All right, thanks.